Good morning. My name is Mr.Hawraz Mohammed. I'm assistant lecturer at the University of Suleimani, holding a degree of civil engineering and the co-founder of Penetro in Iraq. Today, I will be discussing the topics of durability, of course, of the best construction material used, which is concrete. Every engineer is aware of the concrete and how popular is this material. Concrete, of course, is used everywhere. High-rise buildings are made of concrete. Storage water tanks are made of concrete. Bridges are made of concrete. And even roads are made of concrete. So this material has its own pros and cons, has its own advantage and disadvantage. Regarding the pros of concrete, we know that concrete is not a natural occurring material. So it is designed in laboratories and in batch plants. That's why we can have different kinds of concrete for different purposes. Regarding weight of concrete, we can have normal weight concrete, we can have low weight concrete or even heavy weight concrete. And regarding the strength of concrete, we can have low strength concrete, which is normal used for lean concrete, and we can have normal strength concrete with compressive strength reaching 25 megapascal. Further, we can have high stress concrete, which has a compressive strength between 50 megapascal to 200, or ultra high concrete having a compressive strength more than 200 megapascal. This material is a versatile material. Apart from that, you can design different types of concrete. This material can be constructed in different shapes because it's casted on site. Today's topic is not about the pros of concrete, but more we will focus on the weaknesses of concrete. If you just go to the weakness. Yeah. Some people believe that concrete can do everything, but others, they have a different belief. So let's see. You know that the tensile strength of concrete is not as much high as its compressive strength. We all know that the tensile strength of concrete is only 1/10 of its compressive strength. That's why steel bars are embedded in concrete to increase tensile resistance. Apart from the tensile strength, another topic of concrete is whether this material can serve to its design life or not in real life. Many people think that concrete has a good lifetime, but others believe that concrete will not perform to its design life always. And the situation and the condition where the concrete is put describes the lifespan of concrete. So, move to the next slide. Yeah, this material, which can be seen as a very compact and dense material, actually is not that. Concrete is a porous material. It has a structure more like a sponge, and concrete absorbs water, gases, and that's why, according to American Concrete Institute, it states that no concrete is absolutely waterproof or watertight. This opens a new perspective regarding the durability of concrete. You know, and when concrete absorbs water or gases, it will face many issues, which is known as volume change. This could be due to water absorbed and causing freeze and thaw cycles, or water entering concrete and making problems of corrosion, which in turn results in more cracking of concrete. So move to the next slide. So right now, when we all know that this material is a porous material and absorbs water and gases, people know have this for so long. So they're thinking about how to protect this material and give it like more lifespan. According to ACI code, the transport of deleterious material within hardened concrete has a great effect on the durability of concrete. Right now in the world, also in Iraq, people has used many different methods to increase the durability of concrete, especially in critical conditions. By critical conditions, we mean concrete which are exposed to water, let it be rainwater or groundwater. Concrete when exposed to chemical attack, let it be chlorine or sulfate. And concrete exposed to corrosion due to presence of coarse water. Traditionally, there are a lot of methods that people use, and I'm sure you are familiar with some of them. If you could just go one by one. Yeah, from the first photo, we have a guy which is trying to paint a wall. Actually, this is the exterior wall of a water tank. And since it will be backfilled and there will be the risk of groundwater on the concrete wall, these people are trying to paint the wall with some kind of polyurethane waterproofing membrane. Next slide. In here, this is a sheet membrane system you are all familiar with, especially used for roofs. Next one. This is also the basement of a commercial building. The people are trying to coat it with a bitumen extended polyurethane membrane. And this is the interior of water tank. They are trying to coat the concrete with a cementitious waterproofing product. By seeing these photos, we all confirm that today in the Iraq or everywhere in the world, no concrete is left to serve on its own in critical environments. As it's clear from the photos, many different methods and different materials are applied to concrete. That's just to protect the concrete. Those products that you see, we will be focusing on their problems. Okay. All those materials that we showed in the previous slide that consist of different products, they have some weaknesses. Let me show you. First of all, any product like polyurethane paints or sheet membranes or cement-based product, they all depend on skilled laborers. I mean, if you have a concrete or if you have a basement or if you have water tank and you try to protect the concrete on its own, you cannot unless you have a skilled labor. And these products usually cannot be applied to concrete every time. During rain weather, you cannot use these products. And when the temperatures are above 35 degrees, you cannot apply these products due to blistering. And they all rely on minimum thicknesses. So that's why you have to control the thickness of the membrane which supplied to concrete. And all of these products which are applied to concrete to protect the concrete, they need protection as well. And these products are not serving for the lifetime of the concrete, but they will face degradation. So let's see what we have code them to increase the density of calcium silicate. Actually, as is shown from the photo, when concrete is exposed to water, there is a possibility of water going through the concrete and taking the passages of micro cracks and capillaries and making problems for the concrete. So basically, these admixtures and crystalline admixture, what they do, they will react with water that entered into the concrete and grow crystals until blocking the passage of water in the capillaries. Will you move? Okay. To show the effect of crystalline, actually, we have a test which is called the DIN 1045, in which, as shown in the photo, cubes of concrete are exposed to water pressure, and it will usually stand up to 72 hours. And after 72 hours, the cubes are broken in part, and the depths of water penetration are recorded. So according to ACI, reduction in penetration of water up to 90% has been recorded by modifying the property of concrete and making the concrete self-defense. نازم صوتهم شلونه؟ صوتهم كذا؟ والله نازم أبير نانا هم كزم نقدر زور باش هذا بشول ستايلات بقرروا زاد البرو بحشور السر أدمكستر يكون بلا طب so what the Penetron Admix does is usually the Penetron Admix is based on the article of ACI code, and it's a crystalline additive which can be added to concrete to modify its property and change its nature from a porous permeable membrane to a non-porous self-resisting material. Now let's see how Penetron works inside concrete. Play.
Has a multitude of micro cracks, pores, and capillary tracts through which water enters the concrete. When Penetron is applied to the concrete, the structure will gradually dry out, even when facing high hydrostatic pressure. Let's take a closer look at how this works. Water passes through the capillary tracts and micro cracks in the concrete. These pores have a width between 0.1 millimeters and 0.05 millimeters. When when Penetron products are applied to the concrete, the chemical reaction that follows causes these voids and cracks to be filled with insoluble crystals. Water is unable to pass through these crystal formations, and as a result, the concrete becomes waterproof. The ability of Penetron products to penetrate deep into the concrete structure, even when applied from the negative side and against high hydrostatic pressure, is the result of a complex chemical reaction involving osmosis, dry particle reactions, and grounding movement. Once inside the concrete, the Penetron components react with water, calcium hydroxide, and aluminum, as well as various other metal oxides and salts contained in the concrete, and moving through the capillaries. The crystalline formation that ensues as a result of this reaction prevents water from moving through, but still allows air to pass, thus avoiding vapor pressure to build up inside the concrete. If new cracks appear throughout the life of the concrete, Penetron crystals will appear in these cracks as well, preventing water from finding new ways to get through. No more water is present inside the crack. The Penetron crystals lie dormant, but as soon as water reappears, crystalline growth is resumed. In addition to the protection of the concrete against water penetration and resulting damage, Penetron protects the concrete against attack by various chemicals, acids, industrial waste, and corrosive groundwater, as well as seawater, and improves the frost resistance and strength of the concrete.
Bro. So we have talked about the conventional systems that use it to protect concrete. Now we will focus on the advantage of using this additive crystalline to modify the property of concrete and get rid of applying external paints. As you see, this photo is from a project in Suleimania. The basement walls are protected before backfilling. That's because not durable concrete are used, but normal concrete are used. If we modify the property of concrete by adding Penetron admix, we will not need to apply such materials to protect the concrete. Move to next slide. This photo is actually from a project inside Suleimania. The client added the Penetron admix at the day of concrete. As you see, we have the concrete truck. Actually, that was just to show that by using the admix at the day of concrete, we save a lot of time, which dedicated to conventional systems. Here's another photo showing differences between working with conventional system or adding the Penetron admix. The photo from the right shows the basement of a building, which is also in Suleimania. After applying the protection layer, they provided the polyethylene to protect the membrane, the waterproofing membrane. However, when Penetron admix is used inside concrete, you don't need to provide extra protection, which means you will save time and money as well. Penetron products, because Penetron is a global company, and all the products of Penetron has entered the market of Europe, South America, Australia, and of course Middle East. They have undergone a lot of laboratory tests. We as Penetron Iraq also carried out a research on the effect of the Penetron admix, especially on the compressive strength of concrete, and to see how this will implies to changes of the compressive strength. It's a photo of me working at the University of Suleimania lab. We also carried out lab tests at the Pasha concrete plant. Here we see from the chart the yellow bar, which is the control sample with no additive, has an average compressive strength of around 50 megapascal. The P2 and P3 samples, which are the samples of concrete containing Penetro admix, as we see, we have around 20% increase in compressive strength, giving an average value of around 60 megapascal. This is due to the fact that once inside the concrete, the Penetro admix start to make growing crystals, and all the capillaries and microcracks will be filled with calcium silicate crystals, and we will have a more compact and denser concrete, as it is obvious from the 90 days test. بخش هون ما بس دبل كليك لسر أنا بقرره دبل كليك لسر وبري أوسرك. Here's a test from international laboratory from USA. Maybe it's not very clear, but here we have the samples containing the Penetro admixture. There is no any sign of water penetration. However, the control sample with no additive water is penetrated around 2 centimeters. Double click later. Here's another test which is carried out in India. It states that after curing of 28 days, permeability test on the cube as per DIN 1048. The result says that extent of water penetration is 0. The ACI code clearly states that the permeability reducing admixture can be incorporated into any concrete. However, usually it is incorporated into concrete which is exposed to critical environment. Critical environment we have in the basements of buildings, we have in water tanks, even concrete slabs exposed to weather injection is considered a critical environment. Using of the Penetro admixtures to eliminate the problems of water migration, leakage, and freeze and sowing, corrosion, and carbonation. Actually, we have many references around the world and Iraq, but I could just only prepare like 5-6 samples. Here it's a wastewater treatment plant. The concrete is treated with Penetro admix. In this building in Saudi Arabia, the Penetro admix was added to the concrete for the protection of foundation slab, the basement, and the storage tanks. Here is the roof in Suleymania, and the Penetro admix was added to protect the concrete. Here's a pool in Najaf where Penetro admix was added to concrete to get a durable concrete and to eliminate protection with conventional systems. Thank you very much for your time. I especially thank Mr. Ilham and Tishk University for arranging this opportunity to introduce new materials that will benefit the market and the industry. I would like also to thank Mr. Walid, the project manager of Dilishar, that today joined us. Thank you very much. Thank you for all the students who participated, and thank you for your patience.